All right, new lesson 5.1 to 5.2a. This one is all about perpendicular bisectors, medians, concurrent lines, all these great words. So don't let the blank screen fool you. Anyway, today before we start, I want to review with you what a perpendicular bisector is. Perpendicular bisector, again, splits a line into two equal segments. So there's a line, and this bisector can be through it or touch it. It splits it in half. If we have a triangle, remember we talked about perpendicular bisectors not going, just being perpendicular. We used a straight edge for that with the card, those orange cards I believe we gave you. Okay, angle bisector is the next one. An angle bisector splits an angle into two equal segments. So if this is angle ABC, angle ABC is bisected by line BX. So those are two equal angles in there. And then we also have a median. A median we'll talk about in a minute, but a median has a midpoint on it. So when you hear the word median, just think that. So median. All right, let's go on with the lesson. So a perpendicular bisector is a line or segment passing through the midpoint of a side. It's perpendicular to that side. So there's two things you want to pay attention to. Midpoint, and it's perpendicular, and that's it. Okay, and you can have other perpendicular bisectors on this triangle. There's 3 of these for every triangle. If we had an equation that we had to do with this, then it would probably be something like, if this is 2x, and then this is x plus 3, and it's a perpendicular bisector, you would have to notice set up the equation 2x equals x plus 3. So that's the kind of equations you'll see. Angle bisector is a similar thing. It splits the angle into two equal angles. So a simple equation for this one would be something like angle ABD equals 3x, and angle ABC equals 80. And I asked you to find the measure of, the measure of angle DBC. Then what you would do is you'd say, okay, this one's 3x, this one's 3x, the whole thing is 80. So you'd go like this, 3x plus 3x equals 80, or 2 times 3x. Next one is a median. A median comes from the midpoint up. It goes from the midpoint, so this is the midpoint, to the side, to the opposite vertex. So it has to go to a vertex, and it's the midpoint. Those are the 2 words you need to pay attention to. So this would be similar to the one you saw for the perpendicular bisector, where you could have like 2x here, and well, here we'll do a different one. 2x and then 10 is this whole thing. So the equation for this would be 2x plus 2x equals 10. Then an altitude is a segment from a vertex of a triangle. So it goes from a vertex, and it goes perpendicular to the opposite side. The only thing, really, attribute you can get from this is that this is 90 degrees. And so if you had an equation like this, it said this is 3x at this angle. Find x. So 3x equals 90 would be your equation for something like that. So you're going to get various scenarios with the expressions, but this will help you set up the equations. Concurrent lines are 3 or more points, lines that meet at a common point. That's the definition of point of concurrency. If I ask you to find the point of concurrency, you're going to be looking for several types. There's a circumcenter, there's a centroid, incenter, and orthocenter. So if I ask you to find the point of concurrency, these are the words that I want you to use on this. I don't want you to say point of concurrency. I want you to say those. Okay, the first one is a circumcenter. Notice that these are perpendicular bisectors in this triangle, and there's 3 of them. There's this one, and this one. It happens that if you create the perpendicular bisectors for all the sides of the triangle, and notice none of these go through the vertices, they're just perpendicular to the side, and that's it, then where they cross is called the circumcenter. So when I have you draw on your worksheet to draw and label the drawings, I want you to put all these marks on it. I want the congruency marks, and I want you to label the point of concurrency. And I also want you to put the perpendicular marks on there. Okay, so don't just go and say point of concurrency, right? In center. You're going to have to figure out the in center for some drawings on your worksheet. So you're going to do the same thing. Notice there's 3. These are angle bisectors. Angle bisectors go with in center. So they all cross at the same point. It's in center. And that's for all of the angle bisectors for the whole triangle. There's 3 of them. Centroids, same thing. This is the point of concurrency. This is the medians. Medians go from a vertex and they split the side. And there's 3 of them in a triangle. 1 for each corner and 1 for each side is where you put those points. Orthocenter is the point of concurrency of the altitudes. Altitudes go from a vertex and they're 90 degrees to the side. So when you draw these, you're going to have the symbol of 90 degrees right there. You're going to label the orthocenter, and it's got to be perpendicular. So if your perpendicular line looks like, let me do a better line. If your perpendicular line looks like this, that is not 90 degrees. So don't go and put something like that. It needs to be exactly as close as you can get at 90 degrees. The worksheet tells you also to put, to use your compass for the angle bisectors. I think you can approximate them pretty well without your compass. If you want to get fancy and do it, just Google construction for angle bisector and you can try that. But you can probably eyeball it. There's rulers that you can use for that. And again, you've got to put these marks on here when you do these triangles that are on your worksheet. So here's the summary. You've got perpendicular bisector. Perpendicular bisector goes with circumcenter. You've got median. Median goes with centroid. And then you've got altitude. The altitude goes with the orthocenter. And the last one, the in-center, goes with angle bisectors. All right, so that's it. You guys have a great day, and I'll see you when I get back. Bye.